So now, once we understand that as we increase our inductors, it makes it efficient, well, we need our inductors because of mutual inductance. We don't have a choice. But so how do we decrease? We can't really decrease our inductors, right? So we have to find a way to decrease this right here. Not necessarily the inductor itself, we have to neutralize this J. So as this J comes down, right, as your inductors increase, then your J increases, right? But we have to find a way to now decrease that J. So we have to neutralize the inductor with something else, right? So we neutralize it with something called a capacitor. The capacitor behaves the opposite of an inductor. So all we're going to do is, let's just say you have a capacitor. So if you look at Z of the impedance of R, that is equal to its R value. So our R value, let's say, is 100. Our inductor Z value is J omega L, right? So our J, which is 376.8, right? And let's just say we have our inductor at 90 henries, whatever that number is, right? It doesn't really matter. So this is going to be, I'm sorry, yeah, so whatever this number is, so let's skip this for a minute, okay? So whatever this number is, it really doesn't matter. Let's just say that number is 90, right? Or let's just say that number, total number now, is 100. Okay, let's just change that. Let's change this number to 100. So our total Z is 100 plus J100. So I want to get this down as low as possible to J10. What do? Okay, I got to bring this 75% efficiency, 70% efficiency down to up to 99%. How do I do that? I add a capacitor. What does a capacitor do? In this world right here, the capacitor behaves opposite of the inductor. So our Z of C is minus J omega C. Okay? So generally, we're going to have a number down here, right? And you're going to flip the number up. So let's just say whatever that number is, it goes up here. So our Z of C, which we'll do I will show in our calculations later. But this Z of C is a negative sign. You see that? This is a negative sign, so that's a negative J, whatever that negative J number is, okay? So if our negative J is, let's say, I don't know, 90, right? What happens, right? What happens? So our Z equivalent is going to be 100 plus J100 minus J90. Now what happens is that our ZEQ goes from 100 to here. Okay, you see that? So now when you look at our calculations, when we add this capacitor into the circuit, okay, so before our efficiency was 75% with 2 J's at 100. Now we can see that our efficiency has increased because we added a capacitor. So this is 100 plus J10. So now with this minus 90, or that value is at minus 90, we'll make it a plus J10. Okay? I hope that makes sense for all of you.